Assalamualaikum and selamat sejahtera. In this video, I will explain the operation of single-phase and three-phase inverters. Typically, inverters are used to convert DC voltage to AC voltage. Today, we can find inverters in many applications such as the adjustable speed motor drive system, solar power system, and uninterruptible power supply system. Now, let's look at the circuit topology of inverters. For a single-phase power system, we can use either a half-bridge or full-bridge inverter. The only difference between both inverters is the number of controllable power switches. In the half-bridge inverter, two capacitors are needed to complete the circuit. Since the inverter has an opposite function to the rectifiers, let's compare their circuit topology. I will compare the circuit topology of the full bridge inverter to the circuit topology of a single-phase controlled bridge rectifier. As we can see, the architecture of both converters is almost the same. The obvious difference is the way how the power switches are connected to the input supply and the load. Now, let's focus back to the circuit topology of the inverters only. For your information, each power switch in the inverter circuits is typically connected to a freewheeling diode in inverse parallel connection. Hence, when the inverters are supplying an inductive load, the diodes will ensure a continuous current flow of the inductor current. Next, let's look to the circuit topology of a three-phase inverter. As similar to a three-phase controlled bridge rectifier, the inverter consists of 6 controllable power switches. Finally, when we consider the freewheeling diode, hence we will have this circuit topology of the three-phase inverter. Next, I will explain the basic operation of inverters. As you know, the ideal wave shape of the output voltage waveform is sinusoidal. According to the output voltage polarity shown in both circuits, switch S1 in the half-bridge inverter and switch S1 and S2 in the full-bridge inverter should be turned on to generate the positive half cycle of the output voltage waveform. Instead, the negative half cycle of the output voltage waveform is produced when switch S2 in the half-bridge inverter and switch S3 and S4 in the full-bridge inverter are turned on. For the three-phase inverters, the combination of power switches to generate AC output voltages depends on the type of control techniques. Basic control techniques for both single-phase and three-phase inverters are as follows. To operate a single-phase inverter, you can use either square wave, quasi-square wave, and sinusoidal pulse width modulation or SPWM control techniques. On the other hand, to operate a three-phase inverter, we can apply 120 degrees, 180 degrees, or SPWM control techniques.